Welcome back to Statistics on Catalyst University. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. So in the first probably half of this playlist, the kind of statistical tests that we've been using are what are referred to as parametric tests. They tend to be the most common tests that are covered in most science courses, whether it's biology, chemistry, etc. And those tests are parametric, which means there's a lot more stringent and rigorous assumptions that go into the actual population and the data and so forth. And one of those important stipulations is that the data is normal. Now, what do you do if the data is not normal, if it's not a normal distribution? Well, that's one of the criteria that would cause you to use a non-parametric test. And we're going to start going over some of these non-parametric tests. Now, I'm going to say this. These generally, unless you have some special program like SPSS or something like that, these have to be calculated by hand. In the Excel add-ins, you do not have these options for doing non-parametric tests. So I'll show you how to do them by hand in Excel, and most of them are really not that bad. Okay? Now, one of the benefits of these tests, these are the non-parametric tests, is they can, unlike the other ones, be used on ordinal data. They can be used on ranked data, and then, like I said, if the data is not normal, then your best bet is to use a non-parametric test. Now you can see out of the parametric ones that we've talked about, a paired t-test, which is the dependent t-test, unpaired t-test is an independent t-test, Pearson correlation, that's just normal regression that we talked about, and then ANOVAs. Each one of these parametric tests has a non-parametric equivalent. So if you checked out your experimental design and your data, and you determined that you could do an independent t-test, also called an unpaired t-test, but you knew that your data was not normal, then you could say, let's use the non-parametric equivalent, which would, in this case would be the Mann-Whitney U-test. And it turns out these are two formulas that we're actually going to use. And at this point, I'm actually going to flip over to the Excel file, and I'm going to show you how you can actually perform the Mann-Whitney U-test. And we'll determine if there are significant differences between groups. Now, recall that the Wilcoxon rank sum test is the non-parametric equivalent of the paired or dependent t-test. So that being the case, in one column or one group, we have to have the same number of data points as we do in the second column or group, okay? Because it has to be pretty much just like a dependent or paired t-test. So what I would recommend doing is having your two groups here and then making three other columns. We're going to have the difference, the absolute value of the difference, and then the rank. I also have these over here because eventually what we're going to do is add up the positive ranks, add up the negative ranks, determine our sample size, which we could probably do right now. We're going to eventually calculate our W statistic. The W stands for Wilcoxon. We can actually find our critical value of the W and then our null hypothesis, whether it's rejected or fail to reject. Okay? So let's actually first determine how many samples we have. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our N here is going to be 10. Now we can actually determine our critical value of W, our Wilcoxon critical value. This is the table I said we'd reference back to. So we know our sample size is 10. Let's use a 95% confidence interval, which means that we're going to be using an alpha of 0.05. So that means our critical value for W is going to be 8. So let's come back to the Excel file. Our W critical is 8. Now, we're eventually going to calculate this W statistic. And as you might expect, if this W statistic is less than 8, then we would reject the null hypothesis. But if W is greater than 8, then we would fail to reject. Okay? So let's go ahead and talk about how you actually calculate our W statistic. Well, what you're going to do is you're going to take the difference between one group and the other. So that means I can do 13 minus 5, 17 minus 15, 12 minus 6, and so on and so forth. Now the thing you have to be sure to do here is you have to be consistent. So don't do 13 minus 5 and then accidentally do 15 minus 17. You have to do one column minus the other. The easiest way to do that to not get confused and make an error is actually to program the cells. So what I'm going to do is I'm going to hit equal sign in this cell right here, and I'm going to say let's do this cell minus this one. Okay, and I'm going to hit enter. What I can actually do is then drag this cell down and it will automatically calculate all the differences. That's especially important if you have an enormous data set, because it can be, first of all, it can be very tedious to actually go through all of them, but this also prevents, or minimizes, I should say, any human errors. Then what I need to do is take the absolute value of all these numbers. Again, particularly with big data sets, the easiest way is to hit equals and program it. We're going to do absolute value. So we're going to take the absolute value of the difference. Just like that, hit enter. And then I'm going to drag this down also. Okay, just like that. Now, what I need to do next is take these absolute values of these differences, and I need to order them from lowest to highest. Now it can be tempting to try to do this by hand, but a much better way is to click on the column title and click on data, make sure you're under data, then click filter, and then this little arrow appears. You click on this and you can click ascending or descending. Some people might like ascending, some descending. Ascending will put it from lowest to highest, and you can see that it has now ranked the differences that way. Now I need to order the ranks from 1 to whatever the highest one is. I never include in the ranks any with a difference of 0. So that means my first one is going to be this one, 1. And I'm just going to number just in order. 2, 3, 4, 5, 6, 7, 8, 9. Okay? You notice that there's some repeats. For example, for the differences that are 2, there's 2 of them. So those actually get different ranks, 2 and 3. Same thing for these two 4s. You have 4 and 5. So if you have repeats of the same difference, you don't put them both as a rank of 2 and then go on to 3. You just basically just do 1, 2, 3 all the way up until you get to the highest number. All right, click on difference, not the absolute value. I'm going to click on the other one. There's a reason I'm doing this. What I need to do is now add up all the ranks of the positive ranks and add up all the negative ranks. Well, an easy way to be able to see this is actually just to go ahead and click this arrow that's still by the normal difference and now order those based on ascending. Okay? So that way now all the negatives are on top, all the positives are now on bottom. So again, you don't have to program this, but I find it to be a little bit easier, particularly if you have lots of data. So for adding the positive ones, let's equal sum, and you just highlight all the ones you want to add. Well, these are all the positive ones, so I'm just going to highlight all of these positive ranks, because what you're doing is you're adding up the ranks for the positive ones. Hit enter. So that's 36. Now I need to add up all the negative ones. Equals, let's do sum again. It just adds them up. And now these are the negative ones. See, negative 4, negative 2, negative 1. Add up the ranks there. And that gives me 9. Okay? Now, out of these two numbers, the 36 and the 9, the one of these that actually is important and actually becomes your W statistic is the smaller one. In this case, my smaller one is 9. So 9 is my W statistic. Again, it doesn't matter if that W statistic comes from the positive or negative one. Okay, so my W statistic is 9. So in this case, my W statistic is greater than my critical W. That means I failed to reject. Failed to reject the null hypothesis. And what that also means in this case is that these two groups right here, the before and after, that means there is no significant difference between them. They are not different, okay, statistically speaking. If I had gotten for this W statistic something like 7 or 6, something that's less than the critical W, then I would reject, and that would mean that there are statistical differences between these two groups, okay? So one of the differences here that you can see is when you do a at least by hand, when you do these Wilcoxon rank sum tests, you don't actually get a p-value. What you're actually getting is a critical W, and then you're calculating a W statistic, and then you're comparing it. In some ways, if you want to make an analogy, the critical W is kind of like your alpha, like your 0.05, and then your W statistic is like your p-value. And so if you want to reject, your p-value has to be less than alpha, which is normally 0.05 at a 95% confidence level. So that's a parallel that you can make if that helps you. But in this case, my W statistic is larger than my critical W, and in that case, I fail to reject the null hypothesis. Okay? So that is how you conduct a Wilcoxon rank sum test. Again, this is one of the non-parametric tests when you are assuming, or at least you know, that you do not have a normal distribution for your data. All right, so that concludes this video. Please make sure to like and subscribe, and in the next video, I'm going to go over how you conduct a Mann-Whitney U-test. Thank you for watching this video. We'll see you in the next.